Hey Bexy, how are you, man? I really can't trust that view account in that dashboard from Twitch. It says 0 viewers. uh, who's here? Say hello. Let's fix that. Sure, let's hack into Twitch source code and fix their account. I already tweeted that. Oh, Bexy, you did as well. You're so nice. Thank you. I already did, Bexy. I just tweeted. Say hello in the chat if you are actually here. I mean, mentally and physically. Back to you, by the way. The inspiration for the idea to have to plot the bitmax history today in the live stream. When you were asking on Twitter how to do that with Excel, I figured, well, maybe we should do that with Python. 3 viewers. I'm fine with a small audience. People can always watch it afterwards. I'm not doing it for the live hype. Yeah, I think I will start right away. Doing it for the fans, yeah. If only one person learns how to code, then my job is done. It's all fine. It's more for the fun and to come out of my own comfort zone. So, yeah. Let's see if I can somewhat remember where we were last time. Let's get this over here. And this over here. So if you guys want to follow along, open a new folder, create a Python environment or not, up to you, as long as you have Python running. Okay, so yeah. So let's repeat a little bit. So last time we had the very basics of Python, right? Like variables with the different data types like strings and or integers. You can have arbitrary names for the variables as long as they don't start with numbers or dashes, but they have to start with a letter or underscore. Excuse me. And what else did we have? We had, oh yeah, casting, how to convert from a string to a number, right? Because otherwise we can't add stuff up. Like if you have that and you want to print, print was the function to print something on screen or on the console. Say you want to do my number plus 1. And if we run that, let's do it here. This will tell you that you cannot concatenate the string with an integer, and that's because we need to cast this, basically convert it to an integer first, and then we can do math on the stuff. Same goes with float, by the way, for float numbers, floating point numbers. then you have to use float, not int. Integers are only the full numbers. Hey, 5 viewers. I don't know how correct that is. Probably completely wrong, but how are you guys? I hope you have happy holidays and a good start in the new year. I surely had, now that I'm recovered from the partying. So, yeah, what else do we have? Yeah, string concatenation. If you want to add together stuff, text, like a name, for example. Let's do a nice German word that nobody of you can type on your keyboard. Like that. And if you want to concatenate those two, you type it with the plus sign, add some string in between, like a space, and my last name. And there goes the full German name. I baked rice. How are you, man? So what else do we have? Oh yeah, booleans. Remember the things that have only two states, either true or false. This one is false and this one's true. They are spelled like that with the uppercase starting letter. And yeah, you can print them out as well, as far as I know. Yeah, so this is false, and we can do a second one. This one will then be true. As you can see here. So what else is important to... Hey, David, how are you, man? Hope you're a little bit better. Be honest, are you hangover, or I hope you don't get sick? So what else did we go over? We had the conditionals, yeah, if and else. So if I want to do something like print something on screen if something is a valid statement or true, and then I would write if if my true value equals with the double equal sign. That's important, not the single one, because single one is always assigning something. That's also one of the probably most common errors when you miss one of the equal signs, because most of the time this code won't throw an error. Oh, that's nice. Python actually does this. So in JavaScript, it often doesn't. It will just assign the value to the variable, and the if statement will somehow go through, and you debug your face off finding that stupid little missing thing. So you write that like this, and then you say print my true value is, and we do here my true value. Boom. So now it prints it. If I want something that is executed if that statement here isn't valid, then I would write else colon print nope is false. So and now if we can remove that, and if we now flip that over to false, then the else part is executed, right? So, and important to note, the indentation defines what code belongs in the into the code block that should be executed, right? So here's this one line. This can be, of course, this can be many lines, of course. The same here, and everything that is not that has no indentation is executed as normal. Print finish, for example, like that. So indentation is key in Python because that's how Python knows what code goes together. Okay. Yeah, hope you don't get sick, David. Get well soon. Okay, what else did we have? Loops. Yeah, let's go. What else do we have? Operators. Oh yeah, we also had the different operators to compare values with together. Something like we have a number here like 5, and then if my number is lower than 10, print is lower than 10. Oops, like that. Else is equal to or higher. I think greater is the better suited word here, right? In English, is equal or greater than 10. So 5 is here lower than 10. So this part gets executed. If you put 10 in here, then the else code will run because this here only is true if it's indeed lower than 10, not equal. If you want lower or equal to 10, then we would add here a lower or equal sign. Now this first line is executed as lower than or equal 10, and now this must read is greater 10 because starting with 11, the else block will be executed. So, and the same goes the other way around with greater or equal or only greater. And then there is also not equal to. So this is basically the inverse of the double equal signs. That means 10 would execute the else block because 10 isn't equal to 10 in itself, right? Because Python here sees 10 unequal 10, which is in itself false. So it will execute the else block. Bad Rice asks, why would you choose to build something in Python versus Node? It depends, really. Well, Python, I think, could still be more mighty in terms of scientific stuff than JavaScript. There is more available, as far as I know. But Node.js, which is written in JavaScript, is for sure catching up to this, I guess. I don't have enough experience with Python to give a really good answer here because, yeah, I'm primarily a JavaScript or Node developer. What I noticed is what's definitely much more easier with Node.js is handling network stuff. So calling APIs, fetching data from the internet and stuff, and also doing asynchronous work, which means imagine you have something that is computational, very hard to do, or a long-running task. In JavaScript, you can basically by default run that and continue running your code. That's a very simplified explanation because that's not always the case. Basically, only if something outside of Node has to do something like imagine you have to load candle data to populate a chart from your database. So you would this would be like one line in Node.js, and the database would do its thing, would fetch that in the background, would prepare all the data. And in the meantime, your JavaScript code can continue running, can do other stuff, handle other network requests and stuff like that. And as soon as the database is finished, it comes back and gives you a callback into your code, and you can continue to process the data that's coming from the database. So that's kind of hard to do with Python, as far as I can tell till now, but I may be wrong because I'm learning Python myself. Funny enough, I read the other day that Python is actually slow when it comes to calculating numbers. So that's funny. Yeah, so yeah, other than that, it's preference thing, I would say. I personally think that, for me at least, JavaScript is often even easier to write than Python. But yeah, that's most likely just an experience thing. The addition of open source for import in Python allows for a lot more data processing to specific models to be used, probably superior in data analysis, whereas Node is probably better for web scraping and simple DB management. Yeah, well, you can do actually really complicated stuff with Node.js. Data processing, well, is a broad term, right? If you just want to add up numbers or do specific stuff for trading, then I don't think that you would actually need Python because the features wouldn't be present in JavaScript. I actually don't believe this. There are, for example, libraries, open source libraries out there that you just feed the numbers and they will calc basic things like RSI and stuff for you. So it's well suited, and some of the open source trading bots are programmed in JavaScript, and this has its advantages. I'm, for example, building quite complicated bus subscription bus architectures, where there's a central bus that waits that you can feed a task into, and the bus will distribute it to different servers, even if you want to. And that's quite easy to do with JavaScript. And I don't think it would be as straightforward with Python. It always depends on what you want to do. You can do a lot with both of them. So I wouldn't necessarily say something like, yeah, this or that is better. Okay, back to the stuff. Booleans, operators, yeah, we got that. And lists. Yeah, let's do lists now. Yeah, advanced calculus, linear regression, data modeling. I'm pretty sure there are libraries for Node.js also. So, well, even TensorFlow.js is now available, right, for quite some time, where I can even do machine learning with JavaScript. So it's catching up, but I would not argue with you that it's not more advanced and more battle proven, right? So that's for sure. Okay, lists is the next thing I want to go through. So lists, or what other languages refer to as arrays, is basically a list of values, like a OHLC data, for example, of candlesticks, right? Like my candle equals, and this is written in square brackets. And now we add the values in between. I have that writing style that I use as a space before and at the end of the brackets to make it more readable, but that's not what usually Python devs do, as far as I can tell from the doc. So write that however you like to. Yeah, now we can add numbers like 1, 2, 3, 4. So this doesn't really make sense for a candle, of course, but we could do something like the first value would be a timestamp. I do something imaginary here, and this would be the open price, like 1000, and this would be the high. Like this, and what was I always get this confused. Yeah, that's the name, and this would be the low, and this would be the close, right? I don't know, something like that. And then there's often the volume at the last value for the trading session. So that's how typically the candles look like if you fetch them from an API, with this being here completely wrong because that's not a timestamp here. But yeah, these values are a valid example. And yeah, what can we do with this stuff? We will now do a little bit of an easier example just to keep the numbers simple. 1, 2, 3, 4, 5, 6. So let's say we want to iterate over all those values. That's one of the most commonly done things with those lists. And for that, there is a special command, and these things are called loops. And I think we actually had that already, so it's kind of repetition also. And you write that by declaring a for loop with this keyword space, and then I define a name like v, for example, in my list. So now we print v. Now let's see what happens. So as we can see here, it prints out all the numbers in the list in the order as they come out of the list, from starting from left to right. So, and that's important because the order is kept as it is here, so they are not coming out random as you would expect. And what's happening here is basically every time, or as long as there are values inside of my list, the for loop will assign the current value, like at first 1, to that variable called v, print it, and then it will repeat the loop, and it will put the 2 into v, print it, and so on until it reaches 6, and it will put that into v, print that, and after that Python sees that my list has no more items, and it will stop with the for loop, and it will continue code execution after the for loop, like here, print finish. Now we see after the loop is complete, it will continue with that line of code here. So right, so that's the very basic thing, and now this can also be a little bit more complicated. You can have something like nested loops, where one loop is inside another loop. That happens quite a lot. You should try not to do that too much because it makes the code quite unpredictable at times. Or hard to understand is a better wording. Yeah, but let's try. So what you can also do is put lists inside lists. Let's restructure that here a little bit. I think that shouldn't be a problem. Yeah. And now we can put in here a list inside the list, right? So here's the other list. And now we put in a list inside the list where we have, I don't know, maybe one. Let's reuse that one like that. Need a comma at the end. And now the next list item for the other list starts. 10, 20, 30, 40, 50, and 60. So, and now if we look at the result, the for loop, our first for loop, will now print those two individual lists here, as you can see. And if we want to loop now through the inner ones as well, you would put another for loop inside here. So we would do for, and then we need a different variable name, of course, like a in. This can be arbitrary names now. Don't have to be one letter. They can also be a whole name, of course. And now, what are we iterating over now? We want to iterate over the list that is currently inside the v variable. So this would be for a in v, like that. So, and now we need to change the output here to a. So, and this does 1, 2, 3, 4, 5, 6, and then the contents of the second list, one after another. Let's step through this with the debugger, so you guys can see what Python is actually doing here. So we will put a breakpoint here and press the debugger button, Python file. So, okay, that did not what I wanted it to do. What's going on? Is there already a debug the current active Python file? Yes. So like that. Oops, what's going on? Is that now? Invalid syntax. Oh, yeah. I pressed the debug button when I was in the wrong file, and it tried to debug the wrong file. So now again. Why won't you stop? What's going on? Oh, the debugger can't stop on a variable assignment. That's interesting. Does this work? Let's continue, restart this here. Interesting. Okay, that's good to know. So if you set a breakpoint on the line that assigns the variable and you run the debugger, it just won't stop there. That's not a feature of the Python debugger, it seems. So, but that's no problem. We will just use this line here. Okay, let's debug this. Okay, so here we are, and we have this list variable. Here we can see the contents of it. First element is the first list. Second element is the second list. And now let's see what the loop does. So press F10 for one step. So now we are in the second loop, or the inner loop. And if we look at the variable called v here, we can see here is now the first list inside of this. And now we print, and now we enter the inner loop. And as you can see, the v is here our first list, and the A element is now the first element of the first list. So this one here. So prints it. And now what it now does, it doesn't return to the outer loop, but because it still has elements to loop over of that first list, these here. So now it will put the 2 in here, and we'll put in 3, and we go 4. You can see it's also on the top left here. 5, 6. Okay, and now we are at 6, which means we reach the end of the first list. And now Python will see that there is no more elements, and it will jump up back to the outer loop, and it will get the next element of the outer list here, which is this element, which itself is a list, and now it will loop over the second list. And we get 10 and 20, 40, 50, 60, and now it's so that the outer list is also finished. Go away. The outer list is also finished. We looped through all the elements, and that means also the outer list is finished, and we are through with the code. That's how the debugger works. So go in here, loop through all of them until the first element is basically done, get the next element in the outer loop, and so on and so forth. Did you guys catch that? That's an important concept to understand, because loops is probably one of the most commonly used stuff in programming. If you have any questions about this, or if I should repeat that, let me know. Sean says it's clear. Awesome. Okay, no more questions, it seems, to this about this. So, okay. And now if you imagine having a file with candle data in it, with open, high, low, close volume data, right? Then you will actually have exactly that. We'll have an outer list, and inside that list you will have inner lists, with each inner list being one candle. And that's a way to loop over them, and process them all in order. Okay, that's it for loops. Let's see what we can do with the lists itself. Lists. You can also, I think that's repetition a little bit again. You can also access individual list items by using the index of the element. Like if we print out, let's just disable this one here. So if you use the index 0 for my list, we will get the first element, which itself is this list. I think we will, let's keep it like that, or let's maybe add something like this here. Of course, you can mix and match the data types that are inside the list. So you can have here some string like XBTUSD or something like that. So now the first item of the list would be XBTUSD, and that's printed here, all fine. So, and you can also target a list inside a list, of course, because, or I will just show the syntax. It's like that, and then we use the first element here, or the element with the index 1, which is this one here, which is itself a list, and now we target the, let's say, the 4 inside that list. So this would be position 0, 1, 2, free. So this is actually the element with the index free, so, which gives us the 4 as expected. So if we go down one list with by increasing this to 2, we will get to 40. So which is this element here. Is that clear how this works? We can also do this in 2 steps, like intermediate value 1, where we do that second list item, or the list item with the index 2. It's actually the third list item because remember, Python, as far as I know, every other language is starting to count at 0, not 1. So this would be 0, this would be 1, this would be 2. So my list 2, we save that inside here, and then we go here with final is an intermediate value 1, and now we take this 3 here, right? So that would be the same in separate steps, and this is basically the short writing for that. Did you guys get that? Let me know in the chat. Wrapping your head around lists is difficult for beginners. I know that from my own early days. So you will all have your fair share of troubles writing those nested loops and using nested lists. Right, David? Okay, we will get back to this again in the code example that I prepared with the history, the wallet history for BitMEX. Okay, awesome. So arrays, what else can we do? Yeah, of course. Let's get back to a little bit of the basic stuff with arrays. So we'll have an easier one. I would just comment that out in case I need it later. Move that down here. My list equals, I need to do here 1, 2, 3, 4, 5. Let's say we want to add something to the list, to my list. So in that case, you would write my list dot append. As you can see here, appends object to the end of the list. That's what we need. So let's use that, and in the brackets there goes the value that we want to add. And this can be an object. Object basically means like quite everything you want. So like text, for example, like that. So now we can see here in the output that my list contains at the last place XBT. We can do multiple additions, of course. And we can also remove stuff from our array. There are 2 ways. You can use mylist.pop and then give it an index that it should remove. Let's say we want to remove the 2, which is on index position 1, right? Because this is 0, this is 1, this is 2, and so on. So this would be 1. Boom. And this removes the 2 out of the list. let's say we want to remove another element. Let's say we want to remove the XBT. Then this would be, we have to be careful here with the index. This is 0, 1, 2, 3, 4. Okay, and pop seems to have some special, pop does something that I seem not to know about right now. Deletes the second element of the array. Maybe I have to read up on that. Let's see. Oh, that's funny. Okay, and now now it works. Okay, the output here wasn't quite correct. I don't know if you guys catch that, but it wasn't showing XBT, which is wrong. Corn, I mean. So that's better to go with a print statement here than to solely depend on the extension output here. Maybe even close that. Okay, so let's look at this. Okay, we removed the 2 out of the list. That worked. We appended XBT and we appended corn. And then we removed the element at the position 4, which is not XBT because it's corn. Because remember, first we removed the 2 out of this, which means that all items following after that 2 will be put 1 to the left in the list, and the index changes, right? So that means the 4 addresses the XBT and not the 0, 1, 2, 3, 4, the number 5 here. Does it make sense? We can just print the intermediate steps. Print my list. Just have to add them here. Print my list. So you can see how this works. Oops. Could also use the debugger. Another one. Okay, now we have a print statement after each step. So that means the first one here we got these 5 numbers. Then we append XBT. Okay. We append corn. Okay. Now we remove the element on index position 1, which would be this number 2 is removed. Okay. And now we remove the element on position 4, and we have to look on the last known state of the list, which one is number 4, and that would be the word XBT. So that's the end result. That's something to keep in mind. So okay, that's that. What else do we have? Oh yeah, reversing a list, also useful. Let's say you have candle data and you want to reverse it because you for some reason you got the data from the newest candle to the oldest candle sorted, and you need it reversed, right? You need from not from old to new, but you need from new to old data, right? So you can't just reverse the list. And how to do that is fairly easy. You simply do my list. Let's do it down here on the last one. My list reverse. Boom. Tuck, tuck. And now we print that out, my list. Okay, and as you can see in the last line, that's now reversed. So seems like David has flaky internet. Can't watch the stream. Oh yeah, there's a second way to remove an item from the list, and that is with the function called remove. So that would be my list remove, and the difference to pop is we don't give that function the index that we want to remove, but we give it the value we want to remove. So for example, corn, and now we print my list again. And now you can see that here that's the stage where corn was still in here, right after the reverse function. And then we removed corn, and corn is gone in the last state of the list. So what else do we have? Yeah, you can get the length of a list, or the amount of elements inside the list with the len function. So let's try that. That's with print and then len my list, like that, or to make it a little bit more clear, more length of my list equals, and then you go here with the len function and you give it the list. That's the thing it should count, which it does, and then here we can output the number of items inside the list, which is 1, 2, 3, 4, 5. So if I add 1 here, now we get 6 and 7 and so on. So that's the lang. And then there is also an interesting function called count. And count, I got that wrong the first when I read this first. Count doesn't count how many items are in there. Count searches for some value and tells you how often that particular value occurs inside the list. So number, and let's say we want to search for corn and see how often that is inside the list. Here we get the 1. So if I add another item which also reads corn, we get 2. This has to be exact, of course. Also case sensitive. Has to be exactly the same. Oh, David is back. Welcome back. So, and what else do we have? Then there is also a function called index. You use that just like you would count, but the difference is this tells you at what position inside the list this particular value occurs the first time. So let's just to make this a little bit easier. So this is position 0, 1, 2, 3, 4. This is 5. This is 6. And this is 7. So, and as you can see, the function index, when we give it corn to search for, will return position 5 because that's where it occurs the first time in the list. This one is ignored. And then there is also, what is there also? What was the name of that? Index. No, index was what we had. Oh, insert. Yeah, right. Let's say you want to insert something not at the end of the list, as we did with append, but you want to add it, let's say, after the first item. So right in between here. You can do that with the insert function. So you would first give the function the index where you want to add. So in our case, that would be the index before. It will add the thing in before that index you give it, and we will use the 1 here because I want it to be in front, between 1 and 2. And now the value. Okay, and now we need to print our list actually. And as you can see, hello is now at index position 1. So that's that. What else do we have here? Add the elements of a list or to the end of a list. Oh yeah, you can also put two lists together. Let's say we have something like that, where we have my list 1 and we have another list, my list 2. So now we get two lists, and now let's say we want to put them together. My list 1, and there is this function called extend, and this will extend list by appending elements from the iterable. And such a list is iterable, so we will just put in the name here, list 2. I'll print that list out, and as you guys can see, now list 1 also includes the items of list 2 at the end. I'm curious if this also would work here. If you could also do something like final list equals, and then just use a plus sign. Oh, final list. Yeah, that works as well. So you could also basically make an addition of two lists and save it into a new list variable. Yeah, okay. Do you guys have any questions? I think that's probably the most commonly used ones when you work with candle data and stuff like that. So I think that should be a good start. Let me know if you have any questions. And otherwise, I will now show you how to work with modules. We will explore that ourselves together. And so what are modules? Let's say you have a quite complicated project, like with not those 10 lines of code that we are doing right now here for example's sake, but you have like thousands lines of code, and that happens really quickly. So you don't want to have all your code in the same file. That gets really, really complicated and messy. And to split up your source code into multiple files but bring everything together, you can write your own modules. And a module is basically nothing different than a single file with some Python code in it, and you can load that file into another Python file and then use its functions variables. And we will do that now. So let's clean up everything, and now we need some example. So let's say we want to print a simple name or something like that, or let's say we want to create the now let's stay with the names example to keep it as simple as possible. Okay. So we want to have a variable called full name, and this should get some that should read Peter Müller at the end of the code. So that's our goal, really. And we have here our two, we already know our data. So first name would be Peter and last name be Müller. Now we want to concatenate those two strings. We could do it in one line. So this is a very, very overkill example right now for using modules. But yeah, it should drive home the point. So let's say we now want to create a function that concatenates those two names and returns the result so we can print it. So let's do this in this main Python file first, and then we will make a module out of this. Let's define a function with it. Build name, for lack of a better name. So we have first name and we have a last name, like that. And little repetition here. So def is the keyword to define a function. Then there is the function name, which you can choose freely. But again, I think it cannot start with a letter, with a number. It has to start with a letter or with an underscore. And then there is the parentheses where you put in any arguments that the function should accept. In this case, there would be two, first and last, just two freely chosen variable names that will be available inside the code block of this function. And we finish that up with a colon. And in the next line, we must indent our code. So Python knows that this is now part of that function. And we use full, just full, a new variable, and concatenate those two together with, something like that. That's okay. Just a space. And now we return the full variable. So this comes out of the function, right? The return statement keyword says that this is what the function should return. So if we now call that full name equals, and now we type in the function name, and this now accepts those two parameters or arguments, first name and last name. And now we print full name, and we get the Peter Müller as expected. So that's a goal, really. So now let's say we want to move that code here, that function, into another file to keep this code a little bit more clean here. So for that, we first, of course, have to create a new file. Let's call this one, I don't know, helpers. A general purpose name for a Python script file that holds all kinds of little helper functions that you can include in your project. Okay, so let's just cut that code out of here and put it into the helpers Python file. Save that. So now this code, of course, won't run anymore. It will say that there is no function called build_name defined, which is completely true because we removed the code. So now how do we get that back in? We use the import command. So that's import, and then we give it the name of the file without the file extension. So helpers. And as you can see, VS Code already is aware of that file. So it already shows auto completion. And now we can access this function called build name via this helpers import. And we do that by simply typing helpers dot and build name. There it is, as you can see. So accept that. And now the code starts working again. And let's see what it does here. So to really drive this home, so let's move that one over here. And we will now debug this and see what Python does. So press F5. Okay, so it stops here at the import. And of course, you always want to import your stuff before you use it the first time, or otherwise Python won't know about its existence. How would it, right? So we import the helpers file or module. After that, the two variables are defined, and now we are calling the build name function from our custom module called helpers. And I will set a breakpoint over here in this file as well. So if we now continue, you will see it jumps over into this file, and there are two arguments, the first and the last name. It concatenates it, returns the result. Basically, it flies out of that function and is saved into the full name variable. So let's see if I press F10 again. Yeah. So now we are again back in the main Python function, and here is now the full name ready for us to be printed. Boom. There is the result. Or if we go back here. So that's how the modules work. And you can also do that with variables. So you can define here something like list of names. And we do a list here like Peter, David, Fred, Bexy, something like that. And if we go over to, let's move that back here. If we go over back into our main file, we have imported the helpers. And if I now start typing helpers and press the dot, you can already see there is the list of names available for us. So I can print that out here. And if we go to the results page, so there's something wrong. Oh, I accidentally typed an S here. So now it's working again. As you can see, here is the list of names as defined in our helpers file module. So that's the basics of modules. And yeah, that's super useful and easy to use to organize your source code. And of course, you can also put your modules into another folder. I actually haven't tried it yet, but let's find out, because I'm also learning Python here with you guys together. Say my modules, for example, and we move the helpers into that folder. So now it's in here. So this doesn't find my modules. Okay, I see. And now you would use Does this work? No. Oh yeah. Okay. I think what we need to do now is to give this a name with, I think it's as, and then helpers. Yeah, right. Now it starts working. So that's a little neat trick that the import system has of Python. If you have something in a directory, then you would address the module like a path by using the dots in between, right? So here's the folder name here, and here is the name of the module file. And we can then use this as statement to give it a shorter name that we can use. We should also be able to remove that and just use the full path all the time, like so. That should work as well, I guess. Here also. Yeah, that works again. So now we are basically using the whole thing all the time. And I think we could also remove this, right? Can we? No, we can't. So we have to include that that helpers module file also in the path. Yeah, but that doesn't work. So yeah, to sum this up, if you organize your modules in subfolders, you have to put in the whole path here, separated with dots, until you reach the module file itself, the name, and then you would need to use the whole path every time you want to use something out of this module files. But to make this easier and shorter, you can just use the as keyword and give it a shorter name. And this should be arbitrary, I think. So you could also do HLP, for example. And then now we just replace that with HLP here and here. And that works again. So this can be a freely chosen name. Okay. Makes sense, guys? Any questions about that? There's also a third syntax with the import stuff. I think which solves another naming problem, and we will get to that in the example code for the bitmix history. Okay, so I will. I have to go to the bathroom really quickly. So short 3-minute bathroom break, and then we will plot that bitmix history onto screen. See you guys in a second. So yeah, that's right. The modules are really handy. Oh yeah, dictionaries. That's right. Yeah, I think we will. Are they in the other code that I'm going through with you guys? Oh, they actually are. I should probably give them a short spin. Okay. So yeah, dictionaries. Dictionaries um, are a special form of lists. Yeah, don't have a good comparison for them, but they are really handy, and we will use them when we read stuff from Bitmix. So where are they? There we are. So dictionaries, yeah, right. Let's give that a spin. My dictionary. So we just define a variable, and now instead, as with lists, with the square brackets, we use curly brackets. And inside those brackets, we can now define a name and a value for that name. So, for example, you can use double quotes or single quotes, doesn't matter. First, and then a colon, and then the value is Peter, then a comma for the next key value pair, last Müller. So that would be the dictionary representation of those variables. And so dictionaries are very useful to save and handle structured data. And with structured, I mean there are actually useful names that you can use to work with data fields like this. In JavaScript, these are called properties. I'm not sure if they call it the same way here. I think in Python they are just called key. This is the first part on the left side of the colon, and values. So this key value pairs, right? And of course, these can have multiple or different data types, like I don't know, something like that, with integer or floats or what have you. And now you can address or you can get single values of those dictionaries, like name equals my dic, and then you would use square brackets and enter the name, the key that you want to fetch out of the dictionary, like last, for example. Then you would print name, and it should print Müller. Yes. And there is also a second function to do that called get. So this would be first name, oops, my dic get, and then you would enter here the key, first name, and now you get Peter out of this. So that does basically the same. I don't know if there's maybe, I think this one has the advantage using the get that if you happen to ask for a key that's not existent in the dictionary, then you would get none as a return value. That's a special value in Python, which is basically non-value. And while using this syntax with a key that does not exist throws an error. So this is handy because now you can because your code doesn't error out. right? So you can continue working, but you have, of course, you have to make sure to see if first name is actually not none. So it's useful so that you know the value is useful that has come out. You can also test if a value is inside a dictionary with, how was that? If I think it's first in my dic, then print yes. Yeah, that was the syntax. Wait a moment. Name is, oh yeah. So this line of code here would be interpreted like if there is a key called first in defined in my dictionary in my dic, then it would execute this line of code, and if there isn't, then it will execute this line of code. So like if this one would be, I don't know, first name or something, now it would print no because that key doesn't exist in the dictionary. So that's a way, that's very important. Yeah, and that's a neat way to yeah, that pretty much is all we need to know right now. I think there's more that you can do with dictionaries, but for now that should be enough. We can maybe try out how Python prints a whole dictionary. My dic. So, okay, that looks like this. So there is a data format called JSON, which is super commonly used in the web space, and also that's what you get back from the majority of APIs, Exchange APIs. And JSON looks very similar to this, and which makes it very easy to work with in Python, because you can basically convert the response from an API into a dictionary, and then you have all those niceties from Python where you can just get some value out of there based on the key and stuff. Okay, you can also iterate over dictionaries, but we will do that in the code example anyways, as far as I remember. So yeah, let's get to that. Cool. So let's clean up here a little bit. I don't need this one anymore. And I will clean that out. So my goal is to print that print a line chart for the wallet history of your BitMEX account. So for that, you would of course need a CSV file of your history, and for that you would need to go into your BitMEX account, and then you click account in the menu. I can't really show you that right now because can I here in the, let's see, wait a second, maybe I can. Yeah, I can show this here with a screenshot that works. So I will show you guys. Just cut my email address out here. Yeah, that should be fine. Yeah, so. Okay, so here we go. So you go into your BitMEX account, click on the account button here, and like here, after that there appears the transaction history is actually the name, and there is the save as CSV file, save as CSV button, and you click that and you get a CSV file downloaded right away, which basically includes all of this stuff here. So if you want to follow along, do that right now. and I will show you how this file looks like. I have that already ready downloaded here, just need to pull it over. There it is. So this file is called wallet history, and if you download it today, it's probably 2020 0102. I downloaded this yesterday, but I can just rename that to have this the same name as you guys will. So let's look into that. How does this look like? Yeah, where is it there? So that's the inside of this CSV file, and the CSV is a simple structured data file. So we have the first line, which is the columns. This is like a table, right? So each of these fields here, separated by this comma, is a column with the header, the name of the column, and then each line under that would be also the columns, but with the values. So this would be the transaction time, the first one. This would be the transaction type here, the first row of data, and so on. And what we need to do basically is we need to loop over all those entries and take out, make first of all sure that we only use the entries of one. Yeah, we can do that maybe. We could filter this by a symbol, which doesn't make really sense because then because that's the whole account, right? Not based on one ticker. But yeah, for practice purposes, we will do that. But we iterate over all the elements and pull out the wallet balance and print the wallet balance into a simple line chart where the y-axis would be the balance and the date would be the x-axis. You guys will probably have a different date format than me. I think Bitmax localizes this. This is the German, the common German date format. You have probably something like this switched around and stuff, but that shouldn't really be a problem when we code that. So, okay, that's the file. I hope you have that downloaded. In the meanwhile, yeah. So let's do this. Let's move that one over here. Okay. So first off, we need to read that CSV file, right? And for that, we will need our first import of an included module that comes with Python, and this is called CSV. Very easy. So we do import CSV. So this gives us the ability to read CSV files, and next we will open that CSV file and read its contents and loop through them. This goes very conveniently with Python. So if you now believe that I know that from the top of my head, you are completely mistaken. I looked that up by simply Googling Python, read CSV file, and that was basically the code that I found. I think it was on Stack Overflow or something like that. So don't think I'm that smart that I can remember all that stuff. So there is this special syntax. We haven't seen that yet, but we just take this for granted right now. It goes a little bit too deep to explain what this exactly does today. We'll probably do on another time. So, but this starts with open, and open is a Python function that's built in, not part of any external module or something like that, which allows us to open a file on our hard disk. And first of all, we need the path to that file. For me, that's simply the file name, because we are here in this. We are running the code already here inside the same directory as the CSV file is. If you have that somewhere else on your hard drive, I would recommend you for now to move that alongside with the Python file, so you don't have to enter here some path on your hard drive right now. So wallet history 2020 0102.csv. Okay. Next, we need to give that open function an argument called mode, and mode basically defines for what purpose are we opening this file. There are multiple modes. We need the read mode, like we tell Python, okay, we will work with that file, but only to read it. We won't write to it. We won't append it. I don't want you to create it, only read access. And after that, we type in, how does this? Yeah, type in as CSV underscore file. This is just a variable name, so you can choose whatever you like, and the colon. So, and now we basically, with this line of code, said Python, please open that file in read mode and save its contents into the CSV file. And now it will run all the code that we will add here starting in line 4. And after that code is finished, it will automatically close the file for us again. Like in programming, you should always also close the file, and this with statement here does this construct with the with and as. This does this for us automatically as soon as the code that follows below here in that code block with the indentation is finished. So that's the reason for the with statement in very simple terms. Next, we need a way to read the CSV file in a structured way. So we don't just get here line by line in this long string, and then we would have to split the parts ourselves and stuff. This would get very complicated, and there is also already pre-built functions in this CSV module from Python. So, and for that there is a special reader called a dict reader, and we define a reader for that in a variable equals. So reader is also a custom variable name. You can choose whatever you like. And then we use the CSV module, append a dot, and there is a dict reader. And we select that, and we open, and we give it arguments, and we will need to give it the CSV file. So this line opens the file for reading, saves it, saves the handle for the file into this variable, and this variable is then used for the dict reader to read the CSV contents of this file into our reader. And our reader has now the ability to loop over each line in the CSV file and give us the data. So we do this with a for loop, and we call this a row in reader. We will print the row. So, okay, let's see if this works. It doesn't, I already conceded. And why doesn't it work? Because it says here, file not found error, no such file or directory, wallet history, blah, blah. Okay, what's wrong here? This looks like it has double spaces in here. I only typed in one space here, so we'll try that. And now it works. Okay, very, very nicely done, BitMEX. You special guys have effed up your naming here. Okay, now we get that chaos of data. So if I bring this over, it gets a little bit more easy to read. We can see here, we get something that's called an ordered dict. Don't worry too much about it. It's basically the same as a normal dictionary with a little bit of specialties. Just think of it as a normal dictionary as we just had before that code excuse me, that code example. So, but here we can already see there's a transaction time and the date and and the time, transaction type, the amount, the fee, the address over here, transact status, completed, and the wallet balance, right? So it has definitely read something, and it has assigned the column names to the values. So that's somehow here. Now we, but what's this strange thing here? There is the strange control sign in front of the transaction time. And that is because the CSV file that BitMEX is generating is saved in a file encoding called UTF-8 with boom. So, and what we see here are these boom control signs. If you want to know what UTF-8 file encoding and boom is, you're very welcome to read that up on the internet. Just Google that. What it is, basically, yeah, the computer's way of encoding all the various letters and signs that all the languages in the world have. Somehow the PC needs a numeric representation for that, right? And UTF-8 with boom is one of them. And this boom thing, this control character stuff here, is still in the file when we read it, and we need to tell Python that this file is or has the encoding UTF-8 with boom, so it can automatically handle that stuff for us and remove that. And we will do that by appending another argument here called encoding. Oops, like that. And now and I looked that up on the internet, of course. I Googled CSV file, Python, UTF-8, and that is, and boom, and then that came out. So, and I learned that from from experience, from the other coding stuff I do, right? So, yeah, file encoding is a bitch oftentimes, but yeah. I can give you guys the recommendation. Don't try to fix strange signs in files yourself. If you read a file and you get strange letters of any kind, no matter if on the beginning of the line or in between the words or something like that, then you probably have done something wrong or you are missing something with encoding, the file encoding, and it would be the wrong way to try to fix that manually by replacing stuff or something like that. Okay, and the string we need for that for Python is UTF -8 minus sig, and the sig is the special thing we need so that it knows that it's UTF-8 with boom. That's called like that. I don't know why that's how they defined that. So, and if we now look at the result on the right side, those control characters are gone. And everything should be nice and ready for us to process. Okay, let's try to get only a piece of the information and not all at once. Let's try to print out the wallet balance like that, and also what was it called, something with address. Let's see here. Yeah, address. Okay, that looks better. So now I printed the field or the key, the value for the key address and the value for the key wallet balance. So these two values are now printed there, as you can see. So, and I could also do this with the get. So it's exactly the same as I explained previously with the dictionaries. Doesn't really matter in that case because we know that the fields will be here, so I can just use the square brackets like that. So now the wallet balance here is in Satoshi, it seems. So we will need to format them correctly. We will do that a little bit later, I think. Let's see, what's the next thing? Oh yeah, and we need the transaction time. So row transaction time. Oh, that's wrong. Oh, because the field is called transact time, right? Yeah, transact time is the column I need. Okay, so this works. And there is now the date with the time. And yeah, next we can try to plot something. Oh no, let's first create a new list with the data we need for the plot. So we have an x and a y axis, right? And on the x-axis there we need the dates, and on the y-axis we need the wallet balance. So I will define two lists for that. One I will call balance, and this will be an empty list, and this will be our y-axis, and then there is a list called date that will be our x-axis. So, and now we will pull the wallet balance and the transaction time out of each row of the CSV file and save them into those lists. So we'll do that by balance, and then remember we add an item to a list by using the append function, so like that. And we already know that the balance is in this field here. So we just copy that over like so. Okay, I will comment that out for now. And down here, after we looped through the whole CSV file and we already closed it, so with no indentation, we'll print the balance list. And that gives us now all the values of our balance, our account balance. So next we need the date, date dot append row, and we got transact time. Okay, I think we can remove that for now. Now let's print that as well. Okay, there we go. So here's the list with the account values, and here is the list with the dates. Okay, so far so good. And these should have the same length, of course. So we can test this by wrapping it in the length function and see for ourselves. And indeed, they both have a length for 76 for me. So, okay, and now we continue with putting that onto a graph for the first time. For that, we need to add an external module, and I googled that, of course, simply by typing in Python and line chart, and then you get results that tell you how to do this with example code, and that's where I have this from, and I stripped it down to the bare minimum that we need. And we will need the external module called matplotlib. That's the name of the module. .pyplot, and we save that in a convenient variable name called plt. That's exactly the stuff we did previously with our custom module, right? So now it tells us that no module named matplotlib is found, right? So, and that's because it's an external module, we have to add this to our, we have to actually download and add this to our project first. And for that, you will need to open a command line. So you can just pull from the bottom of VS Code or use your PowerShell or whatever you're using. And then here I will just use pip install, I think it's install, yeah, and then matplotlib. So, and that should work. That should download it. I think it's pulling it out of the cache for me because I downloaded it earlier. And now it's added to the project, and the error is now gone because now Python has that module actually. And yeah, the error is gone, as said. So next up, we need to create a plot, a line chart. And for that, we use this plt variable that we defined, plt.plot, and we give it our two lists so it knows what values to plot. First, it needs the x-axis, that would be our dates, and then for the y-axis, it needs the balance. So, and now now to show this, we would just call plt.show. And this should now open up a window where we get this here. So as you can see, it's obviously not right. It's completely wrong, and it's not readable at all. So this needs some work, clearly. So let's close this, and I will also now disable this instant evaluation of the Python code because it will all the time open plots for me otherwise. So let's remove that, close that. So now I will just hit the play button here on the bottom right, and it will execute the file for me and open this once. And when I close the window, and you need to close this before you call it the next time or you will get a mess on your screen, but as soon as you close the window, you're back and you can start it the next time. So yeah, the first thing, if we look at the plot that is obviously completely wrong, is the line itself, right? So that's just going from bottom left to top right, which cannot really be with our values. So that would be a linear increase. Yeah, there is something wrong with the values. And if we look at the CSV file, we can see that these values here are wrapped in double quotes, which means Python, when it's reading it, it will read this as text and not as numbers. And we can verify that by simply taking a look at the balances, print balance, that, execute that, close that. And if you now look here, there are also those single quotes around here. So that means these are not integers or floats, these are strings. And yeah, so Python doesn't really know what value that is because it's not a number, it's a string for Python. So the first thing we need to do is to cast our balances into floats because we have decimal points, of course. So it can actually render a useful curve for us. So we do that with float, and we wrap this whole thing in parentheses. That. So if I now call that again, this should hopefully look better. Yeah, it kind of does. So now this at least looks like a more realistic curve, except this drop. We'll see if that clears up. What is still wrong here is our values, though, because if you now look at my console output here, you can see that the numbers are way too high, and that's because we have here Satoshi values. So we need to fix those. If you look at the screenshot, wherever I have that, where is it? Here. Here we can see that the wallet balance should be 0 dot. It's German, there is a comma because of that, but it should be 0.1657. And here we get 0.568, yeah, rounded down, 567. So this needs to be divided by, so we get Satoshi, this would be 8 places, right? So this would be 1, 2, 3, 4, 5, 6, 7, 8. That should be right. I hope so. Yeah, that should be right. So let's try that. Oh yeah, that makes more sense. So here we got now 0.1658 and so on. So BitMEX rounds this in their UI, so that's the real one, but that's okay. Okay. Now the next problem we need to address is the dates down here. We can't read anything down here, right? Sean asks me, Peter, for Coda, was it pip install Coda? He's using Matplotlib, so it would be pip install. Yeah, that's right. David answered it. So just use pip install Matplotlib. That's all you need here. No need to worry about Coda. Okay, so let's adjust those dates down here. First, we will rotate them a little bit, and there I pulled that out of the documentation, which was a little bit of a drag, but yeah, that's how it is. And there is this function called xticks that allows you to format how the ticks should be labeled. And there is an argument called rotation equals, and then we can define the degrees. We do 55 like that. Let's try this. And now we have these at least rotated by 55 degrees, which is still kind of ass to read. And it's also not aligning very well. And that's because it's using the center of the text, which makes it shift everything to the right. To fix that, there is another argument we can add here, which is called horizontal alignment, or short HA, and we give it a string called right, and that should fix the offset. So as you can see now, the end of the date string now is always nicely aligning with the little dash here. So that's way better to read. Okay. And the next thing we want to do is get get rid of the time because the time is always the same, so we don't need to see that. So this 13 o'clock thing here. So, and as we can see, there is always this comma between the date and the time. So, and we will use that to our advantage to trim that stuff. You can also see that here, right? So there is the date, and then there is the comma and the time. And we will simply split the string using the comma, and then only use the first part of that split and only show that. So where can we do that? We can do that here. So this here pulls the transaction time out of the dictionary, and which results in a string. So that means if I do a dot behind here, I get the options for a string, and I can use split, open the arguments, and then we define a delimiter, which would be a comma here. And this will return a list where the first part is all the stuff before the comma, and the second item of the list will be all the stuff after the comma, or actually with the space here, like that. So, and we only need the first item in this list, so I will just pull out the item at position 0. So so that should get rid of the time. Let's try this. Yeah, it looks good. So now we only have the time here, the date here, not the time. Yeah, that's better. So now what's still missing is the a better formatting here on the left side. A little, maybe. Yeah, we can do that. So there is another. There are ways to format how the numbers, how many decimal places those numbers should have on the axis. They are not very convenient, in my opinion, but quite customizable. And we will use a special built-in object of Python, which is called a string method formatter. Again, I looked that up from the examples of Matplotlib, so that's where you will find that. And there is a special import for that. How we get that is from Matplotlib ticker import string method formatter. Right. So this is a different syntax of importing a nested value inside a module. So we are pulling out the string method formatter from this path here. So I will probably go over this in a future stream, how this works. I have to get my head around this as well a little bit. Yeah, but for now we will use the string method formatter to make those BTC values a little bit more useful, or at least to give you guys a starting point how to use this thing. And how did that work? Oh, hold on a minute. Did I even use that? You guys, I just realized I threw away this because the result wasn't really useful in the end. Let's see, how far did I get here with in the screenshot here? Where is this? Let's see. Oh yeah, I basically left it at this. Oh, my bad, guys. We won't use that. You can, but that would be the one way to change the decimal places and so. But in my tries, this did really improve much of the readability. So for this example, or it would make it unnecessarily complicated for the beginner stream. So yeah, maybe we'll get to this later. I think we will probably plot more charts in the future. Okay, so this is still not completely finished yet. Where is it? Okay, there it is. So because what we can see here is that the dates, the equity curve is basically reversed because we have the oldest date on the right, and while it should be on the left. So what we will need to do is reverse the data. So we can see here, right? Because Python basically reads from the top to bottom, it will start with the newest data and end with the oldest, but we need that exactly the other way around, right? We need to process this from old to new. And this is easy to do. We just need to reverse the stuff. We need to reverse the balances, right? I only reverse yeah, let's see. That should be the first part that we need. Let's see. I'm not sure myself, to be honest. Oh, I forgot to close my chart. There it is. Okay. So that reversed the values. And now we will need to reverse the dates as well, right? Or otherwise we only reverse half of the stuff. That. And now we play that again. And now we have the oldest here, where the count basically gets funded, and then there is the curve of the wallet balance with the newest at the end, as you would expect. Okay, so that's that. And now you can also add some nice labels to the axis by using plt.y label. The y would be xbt, and plot the x label would be the date. So like that. So now we got here those two labels to make it clear what it is. So yeah, what did I miss? Yeah, and now for the purpose of filtering something, it doesn't really make sense. It will actually screw up our curve here, because for the real values we would need to include every trade or transaction, also for Ethereum, for example, not only the XBT ones, right? But let's say, for example's sake, we want to filter out everything that's not XBT USD. So basically the first data set here. For that, we can use a simple if statement in our loop, where we say if, and then we pull out the address, right? So basically this column here which tells us what kind of transaction address was in effect here. Copy that, and we basically only want to append the balance and the date to our two lists if the address in fact equals XBT USD. Let me put our colon in here, and very important, fix the indentation so Python knows that this code belongs to the if statement. So this is an if statement which belongs into the for loop, and this is the code. This will only run if the transaction address was XBT USD. So this should change our graph a little bit. Yeah. So as you can see, now we are at the result with everything filtered out that's not XBT USD. So yeah, and that's how you plot a simple line chart. This plot library is customizable as hell, so you can study this for like probably months to get to all the features. But that's a very basic way to show, to visualize the data, and you could now put all this code into a separate module, define a function, wrap it in a function, and give it, for example, a file name, and then include that module in your next project, and just use that function to quickly print out a line graph, right? Yeah, so do you guys have any questions? Will you do something in the future with live data? Yes, I plan to. I plan to at least fetch data from BitMEX API or something like that. I don't know if we will use something like WebSockets. Maybe I have to look how easy that is to do, because things can sometimes get very complicated. And so we'll have to see if that fits into a stream really, without getting it longer as they are right now. Yeah, but we'll see. It would definitely work with in some way or another with BitMEX API or something like that, or some API. So you get the basics of how this works. I want to plot out some stuff from those move contracts once I can do it without instructions. Yeah. Yeah, sure, Sean. You're welcome. I hope you guys learned something, and have a boilerplate for simply printing something onto screen. And yeah, as an exercise, you can move that code into its own function and use it as a module. Yeah, with that, I will end the stream, I think. So if you don't have any further questions, I wish you guys a good day, night, morning, wherever you guys are. And with that, if you have any questions, hit me up on Twitter, and I will try to get to them and answer them. And with that, see you in the next stream. Bye, guys.